All right, we're going to talk about hydrocarbon practice. Are you ready? All right, we're going to be looking at a worksheet in class, and this is the first problem, and we're going to do this one together. So I'm going to do this one here, okay? And what we're going to do is first look for the longest chain of carbons. So I could go this way, 1, 2, 3, 4, 5, right? Or 1, 2, 3, 4, 5. So I have 5 either way. So my chain of carbons is 5. So I know I have C5 for my molecular formula. Okay. Now numbering them is only going to matter when I get to the next step. All right. So now let's figure out how many hydrogens. 1, 2, 3, 4, 5 across the top, 6, 7, 8, so I have 10. So C5H10. For empirical formula, I'm going to reduce it. Okay, so I can divide both of those numbers by 5, and I don't write a 1, so I'm just going to end up with CH2. Okay, and then condensed structural formula over here is super easy. All right, so it is going to be, I take and I write the C first, C, and then what's connected to it. That's not a C, okay? And I have 3 H's, so CH3, and then what is connected to that? A C, right? And what is connected to it that's not a C? H. Then we have, we're on this one, our next C, and what is connected to it that is not another C, an H. And then we have our next one, which is a C, and what is connected to it that is not another C, 2 H's. And then we have the last one. We have a C, and what is connected to it that is not another C, H3. And we could check and make sure we have 1, 2, 3, 4, 5 C's. 3 H's plus 1 is 4, plus 1 is 5, plus 2 is 7, plus 3 is 10. Perfect. I accounted for everything. All right. Now, we need homologous series and saturated or unsaturated. Okay, homologous series comes from table Q. Saturated or unsaturated based on the series that it's in. Okay, so what I'm going to do is look at that carbon chain, and I'm going to see if I see all single bonds or if I see a double bond or a triple bond. And when I start to scan through it, I see right here a double bond. And then I look, everything else is single between those carbons. So that is an alkene. And when we get to the next examples, we will look back and forth at the table just to reinforce it. Okay. And is it saturated or unsaturated? Well, remember, saturated means full. So that means each of these carbons would have the maximum number of hydrogens attached. But because of this double bond right here, that there are no hydrogens here, right? So it is unsaturated. So when there is a double bond or a triple bond, it is going to be unsaturated, all right? Now for the IUPAC name. So I need the number of carbons, which you said was 5. So I'm going to write the name down here. The number of carbons is pent. That's the prefix for 5 because I had 5 carbons in a chain. It is an alkene, so it ends in -ene. Okay, but if I have something that is not a single bond carbon hydrogen, I have to give an address. Why? You can't just say Main Street. You got to tell me literally where I need to go on Main Street. Okay, what's the address? So if I look at this one, and I numbered the carbons already, right? This double bond is between these 2 carbons right here, right? This is where it is, between these 2 carbons. And the carbons it's between are carbon number 2, carbon number 3, if I number this way. And if I number this way, it's between carbon number 3 and carbon number 4. So what address do you use? You use the lowest number carbon that that double bond is attached to. So that is 2. So it is going to be 2-pentene. Now it's 2-pentene whether it looks like this. So there's carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and then we'd have hydrogens, right? Or if it looked like this, and I counted from reverse, carbon 1, carbon 2, double bond, carbon 3, carbon 4, carbon 5, okay? And then I would have to add, I'll just add the lines for these for hydrogens, because remember, carbon can form 4 bonds, so each carbon atom needs 4 bonds around it. So fun fact, how I'm doing it right now is the way you are allowed to do it on the exam. You do not have to write the H's, but that's the only letter you can leave off. You can leave off an H, okay? So both of these, this one and this one, have the same exact name, 2-pentene, okay? One I just numbered this way, and one I just numbered this way, but they have the same name, okay? That's the first one, and then we're gonna get to the rest. Okay, we just did this one right here together and the last one. So I'm going to skip past that one, but this is the sheet we're working on. Okay, this one starts with just the name, and then I need to fill out everything. Okay, so let's look. First, the ending is ANE. So looking at table Q, do you see this? ANE. So it is, the homologous series is going to be from this column. So I need to put an answer from here. For this one, it is going to be alkanes. Okay. Now, is it saturated or unsaturated? And here's where you have to remember. This one is saturated. These two, because of the double or triple bond. So do you see this one, how many right here, how many hydrogens it has attached to it? And you see how this one has less and this one has less. So it is not full of hydrogens. It is unsaturated. But in our case, it was an alkane, so it is going to be saturated. Oops. All right, next one. What is the molecular formula? Okay, so let's go back and we're going to use this. So here is the general formula, and I'm going to plug in what I have. All right, so I have C5. Oop, not C5. I was going back to the last one. C4, bute, right? And I have then how many hydrogens? So I'm going to plug the N in here. So I would get 2 times 4 plus 2, which is going to give me 10. So C4H10. So that one I'm going to write this way. C4H10. Now for the empirical formula, I am going to reduce it. So I can divide both of these numbers by 2. So I'm going to get C2H5. And I can't reduce anymore, so I'm set. All right. Now the next, the structural formula. So I'm going to draw my carbon chain first, 4 carbons. 1, 2, 3, 4. It's an ane, an alkane, so all of the bonds between the carbons are single. So all I need to do is add enough hydrogens around each carbon so that each carbon has 4 bonds. All right, so here we go, around like that. That's it. I could count around each one and you would see 4 lines around each carbon. And then my condensed structural formula, I write a C first, and then I look what is attached to this C that is not another C. So H3, a C, what's attached to it that's not another C, H2, a C, what is attached to it that is not another C, H2, and a C, and what is attached to it that is not another C, H3. All right, there we go. All right, now we're going to look at this one. This one we start with a molecular formula. Okay, so when you have the molecular formula, empirical formula is easy, right? Both of these numbers can be divided by 2. So CH3 is my empirical formula. I can go to structural formula next. So that's my recommendation. All right, so I draw how many carbons? 2 connected in a chain. And then I have 6 total carbons. So, 6 total hydrogens on the carbons. So 1, 2, 3, 4, 5, 6. Ah, beautiful. So this condensed structure was easy. CH3, CH3. All right, so now let's go over here. Looking at this picture right here, you should just be able to tell, is this saturated or unsaturated? Well, I can see that each carbon is full of as many hydrogens as it can hold. There is no double bond, there is no triple bond, which means now you also know this, that it is an alkane, right? And what would its name be? Well, how many carbons does it have in its chain? 2. And look at this, the prefix for 2 is eth, so it is going to be eth and ane. All right, before we go to the next one, let's look at this. So here is what my molecular formula is. I can also, from here, okay, use the molecular formula to find out which general formula fits. So it was C2H6. And what I want you to notice about the general formulas, do you see how they're all CN? So that's the same. They all start with H2N. That's the same. One of them is a +2, one does nothing, and one is a -2. So what you could do is take the number of carbons you have, double it. So what's double 2? 4. Do I have 4 hydrogens? No. Then it is not an alkene. Do I have less than 4 or more than 4? Well, look here. I have more than 4, which means it was +2, so it's an alkane. So if I had this, C3H6, look at how many carbons you have, 3. All right, what is double 3? 6. Do I have 6 hydrogens? Yes, I do. It's an alkene. All right, so if I had C4H6, all right, how many carbons do I have? 4. What is double 4? 8. Do I have 8 hydrogen? No, I do not. It is not an alkene. Do I have more than 8 or less than 8? I have less than 8. So it is an alkyne. I had to do the -2. So that's a little tip for you, okay? All right, we're going to continue on the sheet. Here we are with this one. And look at the ending, YNE. So I go to this table, and right here, YNE belongs to which homologous series? Alkynes. So it is an alkyne. Is it saturated or unsaturated? Well, do you remember? This alkanes only is saturated, and these are unsaturated. Why? Because looking at their pictures, they're definitely not full of hydrogens, because the double bond and the triple bond remove that availability for hydrogen to bond to those carbons. So this one is unsaturated. All right, now let's come up with the molecular formula. And let's not draw this one first, because you don't have to. I can do this without it. So let's try. Bute, right here, 4 carbons. I know it's an alkyne. So I have C4, right? H, how many? Well, remember, you have to double it. So it is double 4, 8. Do I have double? No, I'm not using an alkene. I have an alkyne. So I got to subtract 2 from that. So it's going to be 6. So C4H6 is my molecular formula. And for empirical, can I reduce it? Well, yes, I can. I can divide both of those numbers by 2. So C2H3. Okay. Now, when you draw it, here's important to remember, I'm drawing molecular. You're not drawing empirical. Molecular is what we need to draw. Okay. So I start with my carbon chain, C, 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 C. Now, this time, alkyne, right, means I have a triple bond somewhere. I can't just put it willy-nilly wherever I feel like it. Okay, I need to look at the address. And you see this? It says, please put it on carbon number 1. So this right here is carbon number 1. So I'm going to put a triple bond right there. And I'm not done. I need to add the hydrogens. But each carbon can only have 4 bonds. Ready? So this first carbon already has 3. So that makes 4. This next one already has 4. Add nothing. And then when I count them up, there should be 6. There is. All right. When I write the condensed structural formula, it's just going to be C with an H, C, no H's, CH2, CH3. Now, I'm going to show you one additional way you could draw this structural formula. I'm going to do it down here because we're only going to do this additional example, and I'm leaving these 2 for you to complete all on your own. So we're just going to use this space. So here's another example for this one. This is not this one. So when I first started by drawing my chain of 4, it's still bute, so I have to draw 4. But I could put the triple bond on carbon number 1, but from the reverse side, so this carbon. So I could put it here. Then I still add the hydrogens, like this. Okay, the structural formula, I could write it the same way because there's no rule that says I have to start at a certain end. But if I wrote it the way that it looks, reading across left to right, it would be this. Okay, these 2 things are not isomers. They're just the same exact thing, just reverse. Okay, so just be aware of that. All right, now we're going to do this last example, pentane. So there's the ending. There's the ending. And look, that's the only one that's saturated. So let's put this here. It is an alkane. It is saturated. Let's write the molecular formula. So go back here. We have C. What did we have? 5. Okay. What's double 5? 10. So were we working with an alkene? No, we are working with an alkane. So we do add 2 to that, double. So it is H12. Okay. So our molecular formula is C5H12. And they do not have any common factors aside from 1. So our empirical formula is the same, C5H12. All right, let's draw it. Pent, 5 carbons. 1, 2, 3, 4, 5. Go back. Do we have any addresses? No, it's all single bonds because of the ane. So all I do is I add the hydrogens, making sure that each carbon has exactly 4 bonds around it. And then when I write the condensed structural formula, I go carbon, what's connected to it that's not a carbon? H3. Carbon, H2, carbon, H2, carbon, H2, and then the end, carbon, H3. I should have 5 carbons. 1, 2, 3, 4, 5. I should have 12 hydrogens. 3 plus 2 is 5, plus 2 is 7, plus 2 is 9, plus 3 is 12. Perfect. There we go. All right, these last 2, 3-hexyne, and whatever this is, I'm going to leave you to try on your own because what I've done so far should have helped you.